I'm building RandomForestClassifier model in Sklearn to predict customer churn. I've trained it using features like age, tenure, and monthly bill. After testing, I get accuracy equals 0.85, precision equals 0.70, recall equals 0.65, F1 score equals 0.67. My goal is to minimize false negatives, wrongly predicting a customer won't churn when they will. So, what can I do to improve my model and achieve this goal? I'm looking for ways to improve my model's ability to correctly identify customers who will churn. This is really important because incorrectly predicting that a customer won't churn is a significant problem. I can increase the number of decision trees in my RandomForestClassifier. More trees usually make the model more stable and accurate, possibly improving recall. It reduces randomness. I can let my decision trees grow deeper by increasing the max_depth parameter. Deeper trees might capture more complex relationships in the data, improving recall. However, be careful. Too deep, and the model overfits. It's a balancing act. This is wrong. Decreasing the weight of the minority class, churning customers, would make the model even worse at identifying them, reducing recall. I should actually increase their weight. While some decision tree implementations let you directly control recall, SKITLEARNSRANDOMFORESTCLASSIFIER doesn't. I'd adjust class weights instead. This is the overall title describing the task. I'm evaluating a model to predict customer churn. I'm focusing on how to adjust the settings, hyperparameters, of a random forest classifier model to get better recall. Recall measures how well the model correctly identifies positive cases, in this case, customers who will churn. The main goal is to reduce false negatives. That means we want to avoid incorrectly predicting that a customer won't churn when they actually will. I'm looking at different ways to improve the model's ability to correctly identify customers who will churn. This is all about boosting the recall score. I can improve the model's accuracy by adding more decision trees to the forest. More trees usually lead to better generalization and potentially higher recall. I can make each decision tree deeper by increasing its maximum depth. Deeper trees might capture more complex patterns in the data, potentially improving recall. But, be careful, making them too deep can lead to overfitting. This is a bad idea. I would never do this. Decreasing the weight given to the churning customers would make the model worse at finding them, thus lowering recall. We should actually do the opposite. While some decision tree algorithms might allow you to directly influence recall during splitting, Sklearn's random forest classifier doesn't offer that option directly. We would need to look for other ways to boost recall, like adjusting class weights. I'm focusing on how tweaking the settings, hyperparameters, of a random forest classifier model can boost its recall. Recall measures how well the model finds all the positive cases, here, correctly identifying customers who will churn. The main goal is to reduce false negatives. A false negative happens when we incorrectly predict a customer won't churn when, in reality, they will. This is especially important because losing customers is costly. To achieve this, I'll focus on improving the model's recall, which directly relates to minimizing those costly false negatives. Increasing the number of decision trees, estimators, in the random forest classifier can make the model more stable and accurate, often leading to better recall. Allowing the individual trees to grow deeper, increasing max_depth lets them capture more detailed patterns, which might boost recall. However, be careful, going too deep can lead to overfitting, where the model performs well on the training data but poorly on new data. This is wrong. Reducing the importance of the minority class, churning customers, will make the model worse at identifying them. We need to do the opposite to improve recall. While some decision tree algorithms let you directly focus on recall when splitting data, the random forest classifier in Sklearn doesn't offer this directly. We'd use _class_weight instead. I'm tackling a problem where I need to improve a random forest classifier model's ability to correctly identify customers who will churn, cancel their service. The goal is to reduce false negatives, incorrectly predicting a customer won't churn when they actually will. The core challenge is minimizing the number of times my model mistakenly says a customer won't churn when they actually will. This is a crucial business objective. I'll explore several approaches to boost the model's recall, which is the ability to correctly identify all positive cases, customers who churn. I can increase the number of decision trees in my random forest classifier. More trees generally lead to a more stable and accurate model, potentially improving recall. It's like getting more opinions, the final decision is more reliable. I can increase the maximum depth of each decision tree. Deeper trees can capture more complex patterns in the data, potentially improving recall. However, there's a risk of overfitting. The model might become too specific to the training data and perform poorly on new data. It's a balance. This is a bad idea. Decreasing the weight given to the minority class, churning customers, would make the model even worse at identifying them. To improve recall, I need to give more weight to the minority class. While some algorithms allow you to directly target recall when splitting nodes in a tree, RandomForestClassifier in Sklearn doesn't directly support that. Instead, I should focus on adjusting class weights. I see you're asking about increasing the maxdepth parameter. This parameter controls how deep each tree in your random forest classifier can grow. A larger maxdepth lets trees grow more complex, potentially capturing more intricate patterns in your data that might improve recall, but it also risks overfitting. Think of it like this. A shallow tree, small maxdepth, makes simple decisions, while a deep tree, large maxdepth, can learn complex rules, but might memorize the training data too well, which isn't good for generalizing to new data. We need to find a balance. Here, you're considering decreasing the weight given to the minority class, customers who churn. This is a bad idea if you want to improve recall. Recall focuses on correctly identifying positive cases, churning customers in this case. By reducing the weight of the minority class, you're telling your model to pay less attention to them, which directly hurts your ability to find those crucial churners. You actually want to increase the weight of the minority class to make the model more sensitive to it. I understand that you are thinking of directly optimizing the decision tree splitting criteria for recall. Unfortunately, the standard Sklearn random forest classifier doesn't offer this direct control over each individual tree's splitting criteria in the way you're describing. It uses either Gini impurity or entropy. Instead of tweaking the splitting criteria individually, a better approach to improve recall here is to adjust the class weights to balance the data. Increasing the number of trees in a random forest classifier, that is, the n_estimators parameter, is usually a good idea. It helps to reduce variance and make your model more stable and accurate. More trees often lead to better generalization and consequently better recall. Think of it like this. A single tree is easily swayed by noisy data, but with many trees, the noise tends to cancel out, giving you a more robust prediction, and potentially a better ability to detect those churning customers. I'm looking for ways to boost the recall of a random forest classifier model. Recall is crucial here because we really want to minimize missing actual churners, false negatives. So I'm evaluating different strategies to make the model better at identifying those customers. Increasing the number of trees in the random forest classifier, meaning increasing n_estimators is a good idea. More trees often lead to a more stable and accurate model, which usually improves the recall and reduces errors. Increasing the max_depth parameter lets the individual trees grow deeper. That allows them to capture more complex patterns in the data. This could lead to a better recall but also increases the risk of overfitting, where the model performs great on training data but poorly on new data. We'll need to carefully choose the right max_depth. Decreasing the class_weight for the minority class, churning customers, is a bad idea. It would actually make the model worse at identifying churners, hurting recall. We need to do the opposite, increase the weight to make it more sensitive to the minority class. While you can adjust splitting criteria to focus on recall in some decision tree implementations, Sklearn's random forest classifier doesn't directly offer that option. We'd adjust class weights instead to tackle this issue. I'm focusing on improving the model's ability to correctly identify customers who will churn. This means reducing the number of false negatives, cases where the model predicts no churn, but the customer actually churns. I've evaluated the current random forest classifier model, and these are the results. The model correctly identifies 65% of churning customers. This is directly relevant to the goal of minimizing false negatives. The F1 score balances precision and recall. A lower F1 score suggests room for improvement, especially concerning recall. The model is 85% accurate overall. While this sounds good, it doesn't tell the full story since our focus is specifically on improving recall for the minority class. This would actually make the problem worse. By reducing the weight given to the minority class, customers who churn, I'll be making it harder for the model to identify them, which directly contradicts my goal. The random forest classifier in Sklearn doesn't offer a direct way to control splitting criteria to optimize recall. Adjusting class weights is the better approach. By increasing the number of decision trees in the forest, I'm improving the model's overall performance and stability. This will likely boost recall. Increasing the maximum depth of the individual decision trees allows them to learn more complex patterns. This could help improve recall, but I must be careful to avoid overfitting. My primary goal is to improve the model's ability to correctly identify churning customers, thereby reducing the number of false negatives. This is crucial for the business.